Organic compounds are essentially carbon compounds. Hydrocarbons are the compounds containing only hydrogen and carbon. Now, we know that carboxylic acids are compounds which are identified by the COOH group. The presence of these two oxygen atoms makes it a derivative of hydrocarbon. Now, let's look at some of the carboxylic acids. The first carboxylic acid is methanoic acid. It has one carbon atom, so its molecular formula is HCOOH, and the abbreviated or the condensed formula can be written as H and a single bond with COOH. Similarly, the second carboxylic acid is ethanoic acid. Eth stands for 2. The molecular formula is CH3COOH, and that is the abbreviated or the condensed formula. Similarly, for the third carboxylic acid, we know prop means 3 carbon atoms, so it is propanoic acid. The molecular formula becomes C2H5COOH, and that is the abbreviated or the condensed formula. Now, so far we have prepared different type of organic compounds. We prepared alkanes, alkenes, alkynes, alcohols. Now let's look at the laboratory preparation of carboxylic acid. Well, the method that we use here is something that we have already used before. So we have used this method, that is, if we start from alkane, we carry out the oxidation of alkane in the presence of catalyst potassium dichromate. It gives us the corresponding alcohol. The oxidation of alcohol gives us the aldehyde, and the oxidation of aldehyde gives us the carboxylic acid. So in order to prepare the carboxylic acid, we can start from any one. We can start from the alkane or alcohol or even from the aldehyde. If we use a particular aldehyde, by using the catalyst K2Cr2O7, we can prepare the corresponding carboxylic acid. So let's take an example. We start with ethane. The oxidation of ethane in the presence of potassium dichromate gives us C2H5OH, which is ethanol. The oxidation of ethanol gives us ethanal. The oxidation of ethanal gives us ethanoic acid. So if we have to prepare the ethanoic acid, we can either start from ethane and carry out the entire oxidation, or we start from ethanol and we oxidize it in the presence of potassium dichromate to get the ethanoic acid. So this is how ethanoic acid or any carboxylic acid can be prepared in the laboratory. Another method to prepare ethanoic acid, which is also known as acetic acid, is by using the catalyst platinum. So initially we had used ethanol. We carry out the oxidation in the presence of potassium dichromate. Now we carry out the oxidation by using another catalyst, which is platinum, at 300 degrees Celsius. So by using platinum as another catalyst, we can also prepare acetic acid and water is released. So by using this method also, we can prepare a particular carboxylic acid. Let's look at some of the reactions of carboxylic acids. The first very important reaction is the reaction shown by all organic compounds. The combustion of all organic compounds gives us carbon dioxide, water, and heat is released. So if we take ethanoic acid, we burn it in the presence of oxygen. So the products remain the same that are for any organic compound. So the combustion of ethanoic acid gives us carbon dioxide, water, and heat is released. Now, if we have any carboxylic acid, we make it react with sodium. We know sodium is an active metal. It substitutes the hydrogen atom from the carboxylic acid and takes up its place. So we get CH3COONA and hydrogen gas is released. Similarly, some other metals are also very active metals, like zinc. If we make ethanoic acid react with zinc, zinc is also an active metal. It takes up the position of hydrogen atom, it replaces the hydrogen atom, so we get CH3COO twice zinc plus hydrogen gas is released. If we take magnesium, magnesium is also an active metal. All these metals, they replace the hydrogen atom. So in this case, and hydrogen gas is released. We get the subscript 2. This is because the valency of zinc and magnesium is 2, whereas the valency of sodium is 1. So in this case, the 1 is ignored, but in case of zinc and magnesium, since the valency is 2, so we get 2 as the subscript. So if we make the carboxylic acids react with the active metals, all the active metals, they replace the hydrogen atom, they take up their place, and so the hydrogen gas is evolved. Let's look at another example. In this case, instead of taking sodium, we have taken sodium hydroxide. Now I've told you before, wherever it's possible for water to escape, it tries to rush out. So in this case, we have hydrogen and OH. So it's easy for this water molecule to escape. So now water tries to escape, leaving behind CH3COONA. And water is formed. So wherever it's possible for a water molecule to escape, it tries to release itself. In the meantime, it forms the following product. So in this case, H from ethanoic acid, OH from sodium hydroxide, they form water, and we get CH3COONA. Let's look at another example. We take baking soda. Baking soda is something which you even use at homes while baking the cake. It gives the fluffy nature of the cake. Now, we use baking soda, that is NaHCO3. All carbonates and bicarbonates, they have a tendency, the tendency to evolve carbon dioxide gas. So if we take baking soda, that is NaHCO3, we make it react with ethanoic acid. So we get CH3COONA. This sodium takes up the place of hydrogen. Now water can be released. This H reacts with OH of the sodium bicarbonate. And since it's a bicarbonate that is used, the CO2 has a tendency to be evolved. So when baking soda is made to react with ethanoic acid, we get CH3COONA. Water is released. And since a bicarbonate is taken, so carbon dioxide is also a product of the reaction. You must have seen erupting volcanoes in pictures or on TV. Well, let's try to make our own erupting volcano. So take a plastic bottle, take some clay. So mold the clay in a manner so as to give the formation of a volcano. The mouth of the plastic bottle can be used as the mouth of the volcano. Fill the bottle with baking soda. You can also add some soap solution to give a fizzy nature. Now get ready for some fun. We'll add some vinegar that you use at home. We'll add some vinegar on the mouth of the bottle. See what happens. Surprise! We have created our own erupting volcano. So what is happening here? In the bottle, we added baking soda, that is NaHCO3. Vinegar is acetic acid, that is CH3COOH. So the reaction that is taking place is, it forms CH3COONA plus water and CO2. The CO2 released is in such a large amount that it gives the shape of an erupting lava. So you can even create your own erupting volcano. Try this at home. Another important reaction given by all carboxylic acids. We have a carboxylic acid. We make it react with ethanol. In this case, we have taken ethanoic acid and we have taken ethanol. So in this case also, if there's a possibility of water molecule to escape, it tries to escape. So this H from acetic acid and this OH from ethanol, they form a water molecule. In the process, they form CH3COO, C2H5. So we get CH3COO, C2H5, and water is released. So wherever it's possible for the water molecule to escape, it does so. And in this process, it forms CH3COO, C2H5. This is an ester. Esters have a very sweet fruity smell. So this reaction can be identified by the presence of a fruity smell, which is nothing but this ester being formed. Acetic acid or vinegar that you use at home for cooking food and various dishes, that is CH3COOH. This is acetic acid or ethanoic acid, or at home we call it vinegar. So this is a very important use of acetic acids in households.